Hello there, and welcome to Astral Quantum, your serene sanctuary beneath the stars, where wonder meets stillness, and science cradles you into peaceful slumber. Before we drift into tonight's cosmic tale, I'd love to know, where in the world are you listening from, and what hour marks your sky right now? Share it in the comments below. It never ceases to amaze me how many of us float together through the night, scattered across continents, yet united by curiosity. And if this journey speaks to you, consider offering a gentle like or subscribing so you never miss our next voyage among the galaxies. Your support helps more dreamers find their way to this quiet corner of the cosmos. Tonight's story is a tender one: how galaxies, those luminous metropolises of stars, emerged from shadow and silence. I hope it isn't so captivating that it steals your sleep. But if it does, at least you'll carry a deeper understanding of the infant universe into your morning coffee. So, settle in. Let your shoulders soften. Breathe deeply. You're about to glide through 13.8 billion years of cosmic evolution. No hurry. The stars have waited eons for you. They'll wait a little longer. Let's begin. 13.8 billion years ago, the universe was small. Not merely small like a closet with no windows, but unimaginably dense, hotter than a stellar furnace, tighter than a physicist's schedule during award season. Then, in an instant beyond full human grasp, it began. Despite its name, the Big Bang wasn't an explosion in space. It was the rapid, elegant unfurling of space itself. Every point swelled outward faster than light could race, like a balloon inflated by a cosmic gust. There was no debris flying through emptiness. Space was the unfolding fabric, weaving itself as it expanded. In those first fleeting microseconds, the cosmos was a seething soup of primal particles. Quarks danced with gluons, photons darted like hyperactive fireflies, and gravity, the ever-watchful architect, began quietly drafting its grand design. It was blindingly hot, wildly chaotic, and utterly inhospitable. No stargazing here. No marshmallows roasting over cosmic campfires. Yet within that frenzy lay immense promise. Hydrogen and helium, the universe's simplest building blocks, coalesced from the charged storm, like elemental Legos snapping into place. From these humble atoms would rise everything: stars, planets, people, pet lizards, and of course galaxies. Around 380,000 years after the Big Bang, a mere cosmic sigh, something exquisite occurred. The universe cooled enough for electrons to be captured by nuclei, forming the first neutral atoms. Light, once trapped in an endless pinball game of scattering, was suddenly set free. This pivotal moment, called recombination, birthed the cosmic microwave background, a faint, omnipresent echo of creation that still hums through the void. If your eyes could perceive microwaves, the entire sky would shimmer with the afterglow of that primordial fire. Yet despite this glow, there were no stars, no galaxies. Not yet. The cosmos was a dark, expanding sea of gas and potential. If you could wander through it, you'd see only subtle undulations, tiny imperfections in an otherwise smooth sea of matter. But those ripples held everything. They were quantum whispers from the universe's first breath, stretched across space by inflation. Some regions were just barely denser than others, almost imperceptibly so. But gravity noticed, and gravity never forgets. Over eons, those slightly heavier pockets of hydrogen and helium drew in more material, gathering like dew on a spider's web. These invisible knots, seeds of future galaxies, were setting the stage for all that would follow. Strange as it sounds, this era was quiet. No starlight, no galactic glow, just the soft murmur of matter folding into itself. A long inhale before the universe exhaled brilliance. Even today, with our most powerful instruments, we're still unraveling how those faint ripples became majestic spirals. Why did some regions bloom into stellar cities while others remained vast, empty deserts? The answers are etched across the sky, in every nebula, every ancient star cluster. We simply need to keep listening. And so the cosmos grew. Dark matter, the unseen skeleton of reality, began shaping the emerging architecture. Hydrogen gathered into filaments. Gravity whispered, and the universe obeyed. Soon, the first stars would ignite. The darkness would end. But for now, the stage was set. The universe was no longer just expanding. It was beginning to become. Stars had not yet awakened. Galaxies still slumbered. And for a few 100 million years, the cosmos remained cloaked in what we call the cosmic dark ages. Don't imagine knights or castles. This darkness was pure, a universe full of matter, but no light. After the Big Bang's radiant overture and the gentle fade of the microwave background, silence settled in. Neutral hydrogen filled space like an invisible mist. No stars pierced it. No galaxies shimmered in the distance. The universe had dimmed, not from lack of energy, but because it hadn't yet learned to kindle its own flame. Picture yourself adrift in that time, an endless ocean of cool hydrogen and helium, electrons drifting like sleepy jellyfish. Gravity tugged gently, forming clouds, but everything moved at a glacial pace. Time itself had no meaning, no clocks, no sunrises, just the slow, patient gathering of mass in a cosmos not yet in a rush. Yet something profound was unfolding in the hush. During inflation, the universe's lightning-fast expansion, quantum fluctuations were stretched across space. These tiny density variations, though faint, caught gravity's attention. Where matter clustered ever so slightly, it pulled more in. Over hundreds of millions of years, these ripples evolved into tendrils and knots, the cosmic web. Imagine the universe as a three-dimensional sponge or a vast spiderweb, woven from filaments of dark matter and gas. Galaxies would form along these threads, drawn by gravity's steady hand. Between them lay voids, immense, lonely stretches where almost nothing would ever shine. At the heart of it all was dark matter, invisible, non-reflective, and utterly indifferent to light, making it notoriously difficult to study and somewhat awkward at cosmic gatherings. Yet it was indispensable. Its gravity sculpted the universe's hidden framework, guiding ordinary matter into place like the unseen armature beneath a masterpiece. Without dark matter, the cosmos might have remained a featureless fog forever. If you're still awake, and if so, I salute your dedication. You might wonder, why did the first stars take so long to appear? Because star-making isn't as simple as flipping a switch. Hydrogen needed to collapse into dense enough clouds for gravity to compress it until temperatures hit millions of degrees. Only then could nuclear fusion ignite. But the early universe moved at its own pace, letting gravity coax gas into ever denser clumps. Slowly, patiently, these clouds collapsed. Somewhere in one such knot, the first spark flared, a single point of light in an ocean of night. And when it did, everything changed. But here, in this long interlude of silence, the universe was still gathering its breath. Like an orchestra tuning before the symphony, all the elements were in place, but the music had yet to begin. No galaxies, no stars, just a growing tension, a sense that something luminous was about to dawn. Perhaps that's the most comforting truth of this era. Even in darkness, the universe was never still. Beneath the quiet, it was dreaming, organizing, preparing. The light was coming. And then, it happened. Deep within a collapsing cloud of hydrogen and helium, gravity tightened its grip. Pressure soared. Temperatures climbed. Atoms were squeezed, so close their very identities blurred. And in that uncelebrated moment, a star was born, the first light since the Big Bang. These were no ordinary stars. Known as Population 3, they were colossal, volatile, and blazing hot, forged in the purest conditions the cosmos has ever known. No carbon, no oxygen, no iron, just hydrogen, helium, and traces of lithium from the Big Bang's aftermath. This purity made them burn hotter and faster than any stars today. Some may have dwarfed our sun by hundreds of times, living brief, furious lives before collapsing into black holes or exploding as supernovae. If you'd been nearby, though you'd be instantly vaporized, you'd have seen these pioneers lighting the void like bonfires in an endless forest. One by one, their radiance pierced the hydrogen fog that had blanketed the universe since its birth. Slowly, the dark began to lift. This epoch is called cosmic reionization. Despite its sci-fi sound, it was a gentle, transformative process. Ultraviolet light from newborn stars stripped electrons from surrounding hydrogen, ionizing it and rendering the universe transparent once more, like opening the shutters of a cosmic greenhouse to let dawn flood in. From our vantage billions of years later, we can't see these first stars directly. They were too short-lived, too distant. But their legacy is everywhere. They warmed the cosmos, seeded it with heavy elements, and laid the foundation for everything more complex than hydrogen, including you, me, and the tea warming your hands right now. In a sense, these stars were the universe's first artists, sketching galaxies onto the blank canvas of space. Yet galaxies hadn't truly formed. Not yet. These early stars often clustered in small groups, bound by gravity, but not yet coalescing into the grand spirals we know. They were villages, proto-galaxies testing the waters of structure. But the ingredients were aligning. When massive stars died in violent supernovae, they scattered enriched material into space. These metals cooled gas more efficiently, enabling faster collapse and easier star formation. The next generation, Population 2 stars, emerged, smaller, more stable, and increasingly familiar. Thus began the great cosmic cycle. Gravity gathers gas, stars ignite, they live, die, and scatter stardust. New stars form from the ashes. Each generation layered complexity like sediment of light. You might ask, how do we know this if we've never seen those ancient stars? The answer lies in ghostly imprints, patterns in light like fingerprints on a cosmic windowpane. By studying the oldest galaxies, chemical traces in ancient stars, and the microwave background's faint glow, astronomers reconstruct the universe's childhood with astonishing precision. It's like deducing a forest's history from its oldest trees, its soil, and the wind's direction. The clues are subtle, but they're there. And now, with telescopes like James Webb, we're glimpsing the earliest galaxies. Chaotic, glowing clumps from just a few 100 million years after the Big Bang. We're peering into the nursery where light first bloomed. It's humbling. These stars lived and died before our solar system was a whisper. Their light traveled billions of years, past colliding galaxies, wandering black holes, the growing Milky Way, until it settled softly on a telescope's mirror, and now rests in your mind as you drift towards sleep. The universe, once dark and mute, had lit its first lanterns. Night had ended. The age of galaxies was about to begin. The cosmos now glowed, not brilliantly, but like the first blush of dawn on a winter morning. Stars had arrived, their light dissolving the fog, warming the silence. But they were scattered, lonely campfires in an endless void, with no cities, no roads, just isolated sparks. Gravity, however, had other plans. Those stars weren't drifting randomly. Invisible threads pulled them together. Everywhere, small clusters converged, drawn into larger structures. Villages became towns. Towns would become cities. These proto-galaxies were the first drafts of what we now call galaxies. It wasn't tidy. There were no blueprints, just chaos. Clumps collided, merged, tore apart, and reassembled. The early universe was a rough neighborhood. Gas clouds crashed. Stars were flung between groups. Some galaxies grew fast, feasting on gas and neighbors. Others stalled in quiet corners, like cosmic wallflowers. At this stage, galaxies bore little resemblance to the elegant spirals or stately ellipticals in telescope photos. They were irregular, messy, more like space blobs than symmetrical wonders. Yet even in chaos, they grew. Gravity and environment slowly shaped them. Much of this structure was guided by the cosmic web, a vast, lace-like scaffold of matter. Where dark matter filaments crossed, dense knots formed, the hubs where galaxies would cluster like seeds in fertile soil. Tendrils stretched between them, guiding galaxies along invisible rails. And between these threads lay voids, silent, empty expanses where few galaxies would ever form. In these crowded intersections, proto-galaxies faced both opportunity and peril. With abundant gas and gravity, things grew dramatic. Galaxies collided in slow-motion dances spanning hundreds of millions of years. These weren't violent crashes in the human sense. Stars rarely hit. They're too far apart. But their gravitational fields tangled. Tidal forces twisted shapes, pulling streams of stars like taffy. Gas clouds collided, compressing violently and triggering starbursts, waves of newborn stars lighting up the chaos. Amid the turmoil, new structures emerged. What determined a galaxy's final form? That's still being unraveled. But we know this. Undisturbed galaxies with steady rotation flattened into spirals like our Milky Way. Those battered by mergers or born in crowded zones became ellipticals, round, puffy collections of aging stars. Others remained irregular, forever lopsided, forever vibrant. Even in their asymmetry, galaxies became something enduring, star forges where gravity and gas birthed creation. Inside, stars lived and died, scattering carbon, oxygen, and iron into space, enriching the galaxy for future generations. Over billions of years, this stardust cycle forged planets, atmospheres, and, once at least, a small blue world where someone would whisper these stories into a microphone. The stars you see tonight are often second dash, third dash, or fourth generation, crafted from the remains of long-dead ancestors. Galaxies are the universe's family albums, each star a page, each gas cloud a new chapter. As galaxies grew, they formed communities, groups, clusters, superclusters. Just as stars gather into galaxies, galaxies themselves are social. They orbit, influence, and sometimes embrace over eons. Our Milky Way lives in the local group, a quiet neighborhood with Andromeda, Triangulum, and dozens of dwarf companions. But that's a tale for another night. For now, the universe had crossed a threshold. It was no longer just gas and light. It had structure, complexity, neighborhoods. Stars had found homes. The cosmos had begun to organize its brilliance. By now, the universe teemed with galaxies, some compact and shy, others vast and dramatic. Stars traced grand orbits. Gas clouds shimmered with newborn light. Darkness hadn't vanished, but it had receded like a curtain lifting on creation's stage. And on that stage, galaxies found their forms. They come in many shapes, like snowflakes, if snowflakes weighed hundreds of billions of suns. Some spin like frozen pinwheels. Others are round as celestial dumplings. A few look like someone sketched a galaxy while riding a roller coaster. How do these shapes arise? Why spirals, ellipticals, or irregulars? The answer lies in time, gravity, and cosmic patience. Spiral galaxies, the showstoppers, are among the universe's most breathtaking sights. With graceful arms and luminous cores, They resemble cosmic hurricanes. The Milky Way is one. We nestle in its Orion arm like suburbanites on a rotating metropolis edge. Spirals brim with gas and dust, perfect for star formation, so their arms glow with young, bright stars. Their structure stems from motion. With moderate spin, gas flattens into a disk. Density waves ripple through it, compressing gas and sparking star birth, creating spiral arms. These aren't fixed structures but patterns, like traffic jams in space. Stars flow in and out, but the arms endure. Not all galaxies achieve such grace. Ellipticals are older, rounder, giant star clouds shaped like spheres or rugby balls. Made of aging, red stars with little gas left. They're the cosmos' quiet retirement villages. They likely form when spirals merge. Orderly motion shatters, stars scatter into random orbits, gas depletes, and a shapeless mass settles. Then there are irregulars, the rebels. Some are young galaxies still finding their shape. Others were distorted by larger neighbors, like hats blown askew. They may look like splatters, but often blaze with new stars, full of chaotic potential. Some galaxies defy categories. Spirals with bulging cores, ellipticals with rings. Classification is messy, because the universe is messy. But shape reveals history. Spirals had calm upbringings. Ellipticals saw ancient battles. Irregulars, perhaps young, perhaps unlucky, or both. Galaxies still evolve today. Spirals can become ellipticals. Mergers reshape giants. Gravity tugs, twists, and scatters. Nothing is static. Hubble showed us this diversity. Galaxies at every life stage, from infant clumps to mature spirals. We've watched collisions, tears, and rebirths. Every galaxy tells a story written in shape. So next time you see a galaxy, spiral, elliptical, or messy clump, remember, you're witnessing billions of years of gravity, light, and stardust. Galaxies don't just shine, they remember. Let's come home now. After wandering the cosmos, it's time to return to our corner, a place familiar not from outside views, but because every human story unfolded here. We live inside the Milky Way, and she's a gracious host. From within, we can't see her whole form, like reading a label from inside the bottle. Instead, we see a river of light across the night sky, the galactic plane, edge on through billions of stars. The Milky Way is a grand spiral, 100,000 light-years wide, holding 100 to 400 billion stars. The range? Hard to count when you're inside the crowd, peering through dust. We orbit about 1/3 from the center, in the Orion Arm, cosmic suburbanites, far from chaos but close to wonder. Her heart pulses with Sagittarius A*, a supermassive black hole 4 million times the Sun's mass. It doesn't devour greedily, but anchors the galaxy. Stars whirl around it like moths near an unseen flame, revealing its presence through their orbits. No, it won't swallow Earth. It's busy being the galaxy's quiet keystone. The Milky Way wasn't always so poised. Like all galaxies, she grew through mergers. Smaller galaxies were pulled in, digested, folded into her spiral. Their stars still drift in her outer halo, ghosts of long-lost homes. This continues today. The Sagittarius dwarf galaxy is being slowly unraveled and absorbed, like ink swirling into water. Even more dramatically, we're on a collision course with Andromeda, 2.5 million light-years away, approaching at 110 kilometers per second. Don't panic. You have 4 billion years to prepare. When they meet, the two will likely merge into a giant elliptical. Astronomers have even nicknamed it Milkdromeda, a bit like space yogurt, but we'll allow it. What's astonishing is how much we've learned from inside the galaxy. Radio telescopes, infrared eyes, and clever math let us map spiral arms, trace star families, and simulate our past and future. It's like solving a puzzle from within, and realizing the picture is vaster than imagined. Our Sun orbits the galactic center once every 225 million years. Since its birth, we've completed about 20 laps. Last time we were here, dinosaurs roamed Earth. Galactic years measure in epochs, not birthdays. So here we are, spinning in a spiral arm, a pale blue dot circling an ordinary star, wrapped in the glow of a billion suns. Every atom in you was forged in stars that died long ago, possibly in galaxies now part of our own. You are literally Milky Way stardust. The galaxy isn't just out there, you carry it within. If galaxies are cosmic cities, who built them? 3 silent architects shaped them: gravity, dark matter, and black holes. None glow or sing, but without them, the universe would be formless. Gravity is the great gatherer. Quiet, persistent, it pulled early ripples into clumps that became stars and galaxies. Though the weakest fundamental force, a fridge magnet, defeats Earth's gravity, it accumulates endlessly in space. No friction, no cancellation. Yet gravity alone couldn't explain galaxies. Stars at their edges orbit too fast. They should fly off like glitter from a spinning wheel. Unless there's unseen mass. Enter dark matter. Invisible, intangible, but gravitationally undeniable. It outweighs visible matter 5 to 1. Every galaxy swims in a dark matter halo, an invisible bubble holding it together. Without it, galaxies couldn't form or survive. We don't know what it is. Exotic particles? Extra dimensions? But its effects are clear, like wind shaping waves. Then there are black holes, specifically supermassive ones. They lurk at the heart of nearly every large galaxy, weighing millions to billions of solar masses. Once thought passive, we now see them as co-authors of galactic destiny. When they feed, they release more energy than all a galaxy's stars combined, blasting away gas, halting star formation for eons. This feedback regulates growth. Their plasma jets sculpt interstellar space across thousands of light-years. Ironically, the universe's darkest objects help hold it together. Dark matter, gravity, black holes, the unseen hands building everything. We orbit a star, in a spiral, wrapped in dark matter, circling a black hole we'll never meet. Every breath happens in a universe shaped by invisible forces. So when you gaze at stars, remember, the beauty is half the story. The rest, the silent scaffolding, is still there, building, always building. Galaxies may look serene in photos, but the cosmos is alive. Galaxies drift, orbit, and sometimes collide, not with violence, but with slow, gravitational ballets spanning eons. Yes, galaxies crash, but stars rarely hit. They're too far apart. It's like 2 fog banks passing through each other, made of stars, gas, and dark matter. Yet galaxies transform. Gravity stretches them into tidal tails, glowing ribbons of stars flung across space. Gas clouds collide, compress, and ignite starbursts, cosmic baby booms. The antennae galaxies show this mid-merger, spirals entwined, arms curling, starlight blazing. Eventually, they'll become one, likely an elliptical, as spiral order shatters in the chaos. This isn't just ancient history. The Milky Way is merging with dwarf galaxies now, and Andromeda approaches, our future dance partner. In 4 billion years, the night sky will shift, then merge into something new. These collisions aren't just destructive, they're creative. They restart star birth, feed black holes, and forge new structures. Like mixing paints, the result is messier at first, but often more vibrant. In this evolving cosmos, Collisions aren't exceptions. They're the rule. Galaxies blend light, stars, and stories. Even now, somewhere, two galaxies begin their slow waltz. One day, they'll unite. A new galaxy will be born, as it always has been, as it always will be. To look into space is to look into time. Light, though swift, takes time to cross the void. So every star you see is a memory. Sunlight is 8 minutes old. Alpha Centauri's glow is 4 years old. Andromeda's shimmer began 2.5 million years ago, before humans, before language, before wheels. With telescopes, we peer even further. Hubble's deep field stared at empty sky for days, and revealed thousands of galaxies in a speck smaller than a grain of sand. Some were 13 billion years old, nearly to the dawn of galaxies. Now, James Webb sees deeper. Its infrared eyes catch light stretched by cosmic expansion, redshifted from the earliest galaxies. Already, it shows us galaxies just hundreds of millions of years post-Big Bang, some surprisingly mature, challenging our theories. The farther we look, the younger the universe appears, but the older the light. We can't rewind time, but the universe sends its memories to us, photon by photon. Our limit is the cosmic microwave background, the moment light broke free. Before that, the universe was opaque fog. That's our horizon. Beyond. Mystery. But what we have is extraordinary. Every Hubble or Webb image is a photograph of the past. Real light that touched a star, then crossed eons to touch you. So when you gaze up, remember, you're not just looking up, you're looking back. Those stars shine from when Earth was young, when no eyes saw them. Yet their light found you. The universe remembers. We've traveled far, from matter's first whispers to galaxies' grand spirals. Now, in the present, the cosmos is still unfolding. Galaxies form, merge, reach across voids. They gather in groups, clusters, superclusters. Our local group holds 50+ galaxies, mostly dwarfs orbiting us and Andromeda, the twin giants of our galactic suburb. Beyond lies the Virgo cluster, hundreds of galaxies interacting, colliding. And further still, the Laniakea supercluster, 100,000 galaxies spanning 500 million light-years, our true cosmic address. All this forms the cosmic web, filaments, sheets, and voids seeded at the Big Bang, shaped by dark matter and gravity. Between the threads lie emptiness, voids tens of millions of light-years wide, silent and stark. Yet not all is growth. Many galaxies, especially big ellipticals, are red and dead, their star formation spent. Even the Milky Way births fewer stars now. We're in a quieter chapter, and the universe itself expands faster, driven by dark energy, a mysterious force pushing galaxies apart. In trillions of years, distant galaxies may vanish from view, their light stretched beyond reach. The cosmos will grow colder, lonelier, but we have time. For now, galaxies surprise us. Telescopes catch echoes of birth, collision, and creation in light that left before Earth had oceans. Every night sky is filled with these echoes. Every star is a story, some beginning, some ended, all part of this vast living architecture. Galaxies are no longer just mysteries. They are companions, teachers, reminders that in a universe too vast to grasp, we belong, and it belongs to us. And now, after billions of years and light years, our journey ends. We've witnessed the universe light up, organize, evolve. We've seen stars ignite, cluster into cities, spin in spirals shaped by unseen hands. We've watched galaxies collide, merge, fade, and age, quiet giants in a cosmos that never rests. We've journeyed through the Milky Way, felt the pull of black holes and dark matter, the quiet architects. And we've looked back in time, catching ancient light that crossed the universe just to meet us here, now. It's humbling, isn't it? To know stars are memories. Galaxies are stories still being written. And everything in you, your hands, your breath, your thoughts, was forged in a long-dead star. You are made of galaxy stuff. You are part of the story. And maybe that's why the night sky soothes us. Why something deep within stills when we look up. Because an ancient part of us remembers drifting through starlight. So now, as your eyes grow heavy and thoughts soften, I'll ask again, where in the world are you listening from tonight? What time marks your sky? Leave a note below if you'd like. I love knowing where these quiet journeys take root across the globe. It reminds me how wonder, curiosity, and stardust connect us all. If you enjoyed drifting through the cosmos with me tonight, consider a like or subscribe for more sleepy science. A whole universe awaits, and I'd love to explore it with you. But for now, rest. Let the stars keep watch. Let the galaxies spin, as they always have. Good night, fellow traveler. You're home among the stars.